We're going to walk through two examples where we revolve a region about the x-axis. We're going to find the volume of the solid obtained by rotating the region bounded by the given curves about the x-axis. Let's look at our first example. The first thing that you want to do with these types of problems is to graph each of the curves that you're given. Just to save time, I've already done that. We have the curve y is equal to the square root of x minus 1, and then we have three lines. X is 2, x is 5, and y is 0. The region that we're going to be revolving is the region that's bounded by this curve and lines. That's this region right here. The radius of our solid of revolution is this radius right here, and you can see that it's equal to y. So the formula that we're going to use is the volume is equal to pi times the integral from a to b y squared dx. And that's because our cross-sectional area is pi r squared. X is going to range from 2 to 5, and this is our y. Let's go ahead and let's put that in. Our volume is going to be pi times the integral from 2 to 5 of y, which is the square root of x minus 1 squared times dx. This is equal to pi times the integral from 2 to 5 of x minus 1 dx. This is equal to pi times the integral of x, which is x squared over 2, minus the integral of 1, which is x, and we're going to evaluate this from 2 to 5. This is equal to 25 over 2 minus 5 minus the quantity 2 squared, which is 4 divided by 2 minus 2. I always write it like this so I don't forget to take that negative and multiply it through to both terms. Let's see what this gives us. This is equal to pi. We have 25 over 2 minus 5 minus 2 plus 2, so that's just minus 5. We'll get a common denominator of 2, so this is pi times 25 minus 10 all over 2, and this gives us an answer of 15 pi over 2. The volume of our solid of revolution is then 15 pi over 2. Let's look at our second example. In this example, we have two curves. Y is equal to x squared, and then x is equal to y squared. We want to begin by finding the points where these two curves intersect, and we want to find the x value because we're revolving about the x-axis, and we're going to use x for our limits of integration. So I'm just going to write down that we're going to find the x intersection points. To do this, we're going to start with our first curve, y is equal to x squared, and then in our second curve, we're going to solve for y, and we get y is equal to the square root of x. So down here, we're going to let x squared equal the square root of x, and we need to solve this equation for x. The best way to do this is to square both sides. So this gives us x to the fourth is equal to x, and that equation we can easily solve. I'm going to subtract x from both sides, and we get x to the fourth minus x is equal to 0. We can factor this, we'll pull out an x, and we have x cubed minus 1 is equal to 0, and this gives us that x is equal to 0, and x is equal to 1. Now we can go back up to our graph and we can see that our two intersection points are 0, 0, and 1, 1. We'll go ahead and label that. Because we have a gap between the region that we're integrating, let me go ahead and let's highlight this in green so you can see that region. We're going to have an outer radius and an inner radius. This is our outer radius, and it is equal to y, and it touches our top curve right here. So y is equal to the square root of x. And then this is our inner radius, and it touches our bottom curve. So that height is equal to y, which is x squared. The formula that we're going to use is the volume is equal to pi times the integral from a to b. We have our outer radius, which is y out squared, minus our inner radius, y in squared dx. This is equal to pi times the integral from 0 to 1. Our outer radius we found was root x, so we have the square root of x squared. You have to remember to square it, minus the inner radius, which was x squared, and we square that one as well. And then we have our dx. Before we integrate, let's simplify this integral. This is pi times the integral from 0 to 1. Square root of x squared is just x, and then we have minus x to the fourth dx. This is equal to pi times x squared over 2 minus x to the fifth over 5, and we're integrating from 0 to 1. It's always nice when we have 0 as a limit of integration because we don't have to do as much work. This is then pi times 1/2 minus 1/5. We'll get a common denominator of 10. So this is 5 minus 2 over 10. And we get an answer of 3 pi over 10. This tells us that the volume of our solid of revolution is equal to 3 pi over 10.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.